Alright, so this video for section 5.7 is going to be a little bit longer rather than breaking up into two videos because it's kind of the same, it is the same thing for both of the videos, so it's just going to be a little bit longer video. So the first thing that we're going to discuss is the Hinge theorem. It's actually what this whole video is about. Alright, the Hinge theorem. In class tomorrow, we will discuss using the door, why this works, but if you think about it, if we have two congruent segments, so these two are congruent, they tell us that. And they're congruent to this triangle over here. So the two sides of a triangle are congruent to the other two sides. If this angle is greater than the angle in between on the other triangle, then that means that the remaining segment must be larger. Right? And if you think about what we've learned before is when we're dealing with the same triangles, what we talked about before is if this side is larger than this side, then I know that this opposite angle has to be greater than this opposite angle. So we've talked about that before. So here we're comparing two triangles where these two sides are congruent to these two sides over here. And the included angle for this triangle is greater than the included angle for this triangle. So that means that this remaining side must be larger than this remaining side. All right, and tomorrow we'll use a door as to why that works. All right, but we're going to go through an example really quick with this. So now, when we're looking at this, it tells us to use the Hinge theorem, but you need to be able to identify when you can and when you cannot use it, right? And we know that we can use the Hinge theorem because on this triangle, they tell us that it is congruent to these two sides for this triangle. And then this side, A, the included side, so the angle A, is greater than the included side for this angle, measure of angle O. So that means that this segment, SK, opposite of that angle, must be greater than the segment opposite of that angle, UY. Alright, so the Hinge theorem, we have to have two sides that are congruent in two separate triangles, and we need to be comparing the angle that's included with those two sides, or the angle between them. Alright, so which of the statements must be true? Well, AS is less than YU. Well, we know that that's, that can't be true there. We don't have enough information for that. It could be less than, but we don't know. SK is less than YU. Well, we know that that is in fact false because SK is across from 90 degrees, which is larger or greater than 70 degrees. So we know that that is actually false. AK is greater than YU. Well, here they tell us that AK is 2 tick marks. YU, they don't put any on there. So that doesn't have to be true. And later on, it tells us that SK is greater than YU, which is what we know has to be true because 90 degrees is greater than 70 degrees. So that means the side opposite of that angle has to be greater than the side opposite of 70 degrees. So that means SK must be greater than YU. All right, so that's the Hinge theorem. And it works in reverse, as you're going to see here as well. If you're given two triangles, where we're comparing two triangles, and these two triangles have two congruent sides. And now the third side, the one that we don't know if it's congruent or not, the one that's not marked up, is greater than the remaining third side of the other triangle. Since BC is greater than YZ, that means that angle A has to be greater than angle X. All right, it's the exact same thing that we did in the beginning, except for now we're not given that the included angle, but we're given the remaining side. All right, but it's the same thing we did before, but in reverse. And remember, when we switch our hypotenuse and our conclusion, that means that it's the converse. So this is the converse of the Hinge theorem. Right, the converse of the Hinge theorem. We're going to do one example with this, and then there's going to be a problem that you're going to hand in. Here it says, what is the range of the possible values for x in the figure to right? So they want to know what values of x can hold true for this problem. Well, when you look at what's given to us, they tell us that LK is congruent to ON and that KM is congruent to MP. So we know that we're going to use the Hinge theorem here because we're given that two sides of one triangle are congruent to two sides of the other. Now we just have to identify, are we using the Hinge theorem or are we going to use the converse of the Hinge theorem? So when we look here, we're given that LM is 7 and that OP is 9. So we're given that OP is greater than LM. So that means we're going to use the converse of the Hinge theorem, meaning that the side opposite of LM has to be less than, so the measure of angle K has to be less than the angle opposite of OP, which is the measure of angle N. So we know that this has to be true on the converse of the Hinge theorem. Since OP was greater than LM, that means angle N has to be greater than angle K. All right, so now we'll just substitute what we have. Well, angle K is equal to 3x plus 18, and angle N is equal to 90 degrees. So that means 90 degrees has to be greater than 3x plus 18. Then we'll just solve for x. We'll subtract over 18. We get that 72 is greater than 3x. Divide each side by 3. And we get that x has to be less than 24. All right, so if x is 24 or more, it won't hold true because that means angle K would either be equal to or greater than angle N, which we know cannot be true. All right, but that's not all the range that we have here, because this angle K, not only does it have to be less than angle N, but angle K can't be 0 or less than 0, or else angle K is not an angle. So we need to also set another constraint on this, meaning that the measure of angle K must be greater than 0 degrees, right? If it's less than or equal to it, then it's not an angle. So that means 3x plus 18 also has to be greater than 0. So we will solve for x in this case, subtract over 18, so 3x is greater than negative 18. Divide each side by 3, and x has to be also greater than negative 6. Because if x is equal to negative 6, that means angle K will be 0 degrees, which means it's not an angle. So these are the possible ranges. It means that x has to be greater than negative 6 and less than 24. Any number outside of this range will not hold true for our Hinge theorem. All right, so that is the last problem that we're going to do. This problem you're going to do in your notes. So it's section 5.7.1 on your notes. You can write it out, take a picture, and put it in your shared document that we had before. So the same question, what is the range of possible values of x? So what values of x can we have? What are the possible values that we can have? All right, that is it for this video, and that's it for this chapter as well.